Hello all, this video is on Modbus over RS485 on DWIN HMI display. Here DWIN display is used as a master Modbus. In the previous video we used the DWIN as slave. Here we are going to implement as master. In this video we have a 5-inch industrial grade display and this has got A and B pins which are RS485. We will be implementing Modbus on these pins and communicate with PC. We require USB to 485 converter like this. This is built on CP2102 and while connecting it to PC it offers a COM port. Through this COM port we will be communicating the Modbus. This HMI display requires 12 volt 2 ampere power source, and for downloading the files generally we use SD card method, and as a supplement I am going to use this UART2 also. So as we have to often download this 22.bin file for modification of master, we will be using this method. That is, T2 is connected to TX of DWIN connector, RX2 is connected to RX, straight connection, ground to ground, and we require RS232 to USB like this. We will be connecting this to another port which will be offering another COM port. Through this COM port we will be downloading the bin file and OS file. So for regular Modbus communication we use the CP2102 USB to RS485, and for downloading 22.bin file and the OS configuration file we will be using the UART2. Now let us open the DGUS software. This is the project file creation. We have 4 background images. First we have to create the 32.icl and then bring in the font file inside the DWIN_set folder. In the first page we have got some VP address variable where we are going to use the data variables. Mainly we will be using data variable, and this VP address allocation is very important. You cannot use VP address like for 5000 as it is being used by the DWIN operating system, that is Modbus OS file. So we are allotting this starting from 1000. In the second page we have some VP locations. Here we use the data variable and the VP addresses are like 2010111213. See, it is very all contiguous, and we will be using another data input variable for implementing keyboard. So on touching this, keyboard will be open and we can feed in the data. And finally at the bottom there is a send button. There we use the return key code, that is 005A. Low byte of 5A is verified for the VP address 3000, and then all the data from 2010 to 2013 are sent to the slave. We will see how to implement in this project. That is, implement the DWIN display as master and then get the data from slave and also transfer data to slave. In the third image we have a keyboard. This keyboard is designed using basic touch. You have to feed in the hex code as shown in this video. You can check our previous videos also how to implement this keyboard. For the keyboard keys, correct hex values to be provided as seen on the screen. For Modbus slave we will be using this freeware pyModSlave. You download it and keep it handy. For OS file, go to the official website, go to kernel upgrade and then scroll down to the MODBUS master and download the zip file. Unzip it and inside that you will find the 115200 OS file. This pyModSlave is built on Python and GUI is built on Qt. It is a freeware. So from project, go to the DWIN_set folder, copy it to the SD card, remove the SD card and plug it onto the DWIN display, provide the power source. You can see the blue screen of downloading the project files. Finally remove the power and then the SD card, provide the power back. You can see the project on the screen. The project has got 2 pages. First page with some data variables, that data is coming from slave, and the second one you can feed from master. You can touch to open the keyboard and provide the values and send it to the slave. From the project go to dgus and then click on t5l download. From here select file and then select the OS file. Go to the downloaded OS folder, select the 115200 OS file. We are going to use the 115200 board for the Modbus, so select the correct OS file, that is the OS bin file. Only the bin file you can select, not the ASM file, and then click on serial port. Now select the port as COM6. Here we have connected the CS340 converter, that is UART to USB converter with the 115200 board. In the device manager you can see the COM port, correct COM port. The other COM port is for Modbus, and then click on download. So instantly the OS file will be copied to the DWIN display. You can see the display blinks once, it goes blank, it means the OS file has been downloaded. Now we have to go to the configuration file. Always copy this configuration file to another place and then modify. Do not modify it from the DWIN_set folder itself. Copy the 22.bin file, place it on the desktop or any other place, and then use the PSPAD editor to edit this hex file. Use the go to location 1C000. Why 1C000? You can check up the data sheet. It says at E000 the Modbus parameter setting starts. As in the VP addresses word, you have to multiply by 2. E000 into 2 is 1C000, so that you can go to that location. This parameter settings you can see in this data sheet, but the new OS, the data sheet has been slightly modified. You follow this new data sheet. The link is given in the description. You can download. As per the old reference guide, at 1C000 you have to enable the Modbus as master or slave, and then set the baud rate and the slave ID. But as per the new settings, everything is done in the OS file itself. You need not configure for Modbus initially. Just straight away from 1C000, straight away provide the Modbus commands. Everything is done in the OS file. You have to download the correct OS file. We have downloaded 115200 Modbus master slave ID 1 OS file. Now straight away we can see the Modbus commands. The first command is 0x10. There are different Modbus commands. You can check in the old reference guide itself. The Modbus master interface 0x10 is master to slave, and it is reserved for multiple registers. You can handle multiple registers from master to slave. Remember, the length of operation is in word, which is equal to 2 bytes or 1 VP. 1 VP equal to 1 word. The Modbus statement starts with 5A, and then the slave ID 01, and then the command is 10, and D3 is the length. We use 01, which means 1 VP we are going to update, and then at D4 we are using 50, which is the timeout. We are using timeout 50 millisecond. 2 to 55 millisecond is allowed. This also modified from the last previous guide. We used to 2 bytes. Now we are going to use only 1 byte D4, and then the D5 is the command, which is very important. 4 commands are there: 00, 01, 02, 03. Mostly used are 00, 01, 02. First is the 00 command, which means unconditional command, which operates on all pages. We need not mention the page ID. If you are using 01, you have to mention the page ID. As it is unconditional, you need not define the D6 and D7, but you have to put 00 there. So at D5 the command is 00, and D6, D7 is also 0000. That is, page ID is not defined. And after that is the D8 and D9, which is the VP address of the master. Here I am going to update from 2010, that is from master to slave. Second, that is the page 1. 2010 is the VP. From there we will feed in through keyboard and update the slave. and then D10 D11 is the slave address, which is 0000. Now save the file, bin file, and we'll be using the tfile download tool. Here you have to select the file as 22.bin file. Remember to select the modified bin file, not from the DWIN_set. We have stored in the desktop and modified just now, implementing the commands. So select the 22.bin file and then select the correct COM port. Here it is COM6, where we have connected the CS340 UART to USB. The other one is for Modbus, and this is for UART2. And then click on start downloading. The 22.bin file will start downloading. So this method is very easy if you are often changing the bin file data. And once it is finished, you can go to the pyModSlave and open the pyModSlave. This standalone software, open it and go to options Modbus RTU and then set the communication port. Here the RS485 to USB is used, and you have to select that COM port. Here it is 4 and 115200 baud, 8 data and no parity and 1 stop bit. This selection to be correct, and the slave ID to be 1, and the Modbus mode is RTU. And below that you can see the PLC memory registry areas, coils, discrete inputs, input registers, and then holding registers. You have to select holding registers. These definitions we'll see clearly in the next video. And start address is 0 and quantity is 10. So this is the first instruction: 5A01 1001 5000 0000 2010 and 000. So from the Modbus slave, you notice the first location 00, and from DWIN master you update the 2010 VP. Touch on 2010, you can open the keyboard as you have set in the project, and then feed in the keyboard. Let us feed in the value 88. Now you can see the slave is being updated at location 00. The slave address 00 is updated from master 2010 VP. So from slave, if you change, the change will not take effect onto master, as this command is from master to slave. So again, from master change the value, the slave address location, the data will change. Now let us see the second instruction. In the second instruction, let us see how to handle two VP address data. That is, the data length is 2 words. Word means 1 VP. Let us take it that way. Word means 1 VP. 1 word, 1 VP. Here it is 2 words. After 10 command, we are using 02 instead of 01. Use 02, and after that the same. 50 is the receive timeout, 00 is the command, and after that 0000, and then the VP 2010, and slave address 00 starts from 0000. Save this bin file and use the tfile download method. Select the file, select file, and go to the modified bin file. Just now we have modified this 22.bin, and select the correct COM port and start download. Only the 20.bin file will upload onto the DWIN hardware. Now you can see the blank screen, and then again screen will be on, indicating that the 22.bin has been downloaded. Go to the second page, page 1, and update the 2010 VP using the keyboard. Now you can see the value has changed in the slave, that is pyModSlave. Same way 2011 also will be effective. Touch on that VP and change the second value. At 01 location, slave location, you can see the changes. So by this way, 2 VP address are handled, 2 VP data are transferred to the slave address locations 00 and 01. So this is the command 0x10, that is master to slave command, and length of data is 02. Now for the third instruction, let us change the data length as 04. That is 4 words, 4 VP address. Word means VP address, and the others are all same, 50. Here we will be using 01 mode. 01 mode means next you have to provide the page ID, which is 0001. Page ID is first page 0001, and the VP address is found on that page 2010. So we are going to update 4 VP address from 2010. Select the same file download mode and upload this 22.bin file, and in the project DWIN hardware, go to the page 1. First is the page 0, second slide to go to the page 1, and you can see 4 VP address 2010. Touch on that VP, feed in from the keyboard some value, you can say 11. It is updated in the 00 of slave, pyModSlave. Same way 2011, 2012 and 2013. Total 4 VP address. Will change the value using the keyboard, and you can see the values being reflected on the slave. This is how to change the 4 VP address data to slave. So this is from master to slave. Next instruction, let us see how to change all the 4 VP address data to the slave at the same time. For this we'll be using 02 mode. After 50 we'll be using 02 mode. In this mode we check the value that at 3000 VP address. In 3000 VP address we have used a return key code, and the key value we have fed 005A and low byte at address VP 3000. So we'll check for the low byte 5A. If the key is pressed, the 5A will be returned, and if it is 5A is returned, then starting from VP address 2010, total 4 VP address data will be transferred at the same time, starting address 0064, that is decimal 100 of slave. 4 VP address data from 2010 to 2013 will be transferred to the slave at the same time when the send button is touched. So the send button is tested for a low byte 5A. Save this bin file and transfer the bin file to the DWIN hardware using T5L download method as done previously. Now the bin file has been transferred. From the DWIN master display, go to the second page, that is a page 1, and then at the same time open the pyModSlave. Starting address is 100 now in the slave, and touch on the first location, feed in the data using keyboard 2010 VP, provide a data. Now you can see it is not yet updated on slave. Go to 2011, 2012, provide some data using the keyboard, and finally 2013 VP. All VP address should be contiguous, it is very important. And then finally touch on send. You can see all the 4 data values has been transferred to the slave starting from ID 100. As we have used 0064 in the instruction, it starts from 100 location, and all the 4 VP address data are transferred at the same time to the slave. This is mode 2, 02. So we have seen 00 mode, 01 mode, and then 02 mode. All these 3 modes are very important. In the next instruction, let us see command 0x03, which is read staying register data. This is from slave to master. This is command 0x03, and the instruction is same, that starts from 5A, the slave ID is 01, and now the command is 03, and then the length of operation of the command is 01. 1 means 1 word. We are going to update only 1 VP, so 01. 50 is the timeout, and after that we use the 01 mode. 1 mode means after that we have to mention the page, which is 0000, page 0, and then the VP is 1000, that is of the master, and then the VP of the slave, not VP, that is the address or location of the slave, which is 0064 in hex. In decimal it is 100. We'll be using in the slave software in the decimal mode only. So open slave mode, that is a pyModSlave in decimal. Now upload the save this file, bin file, and then upload using T5L download method to the DWIN hardware. Now notice the first page. This is the page 0. from pyModSlave we'll be updating the location 00, which is 100 location. You can see the data being uploaded on the screen, page 0 at VP location 1000. Now let us see how to update all the 5 VP address starting from 1010. For this, the instruction is same as that of the previous 5A0103. Now the length of operation, let us change it to 05. That is 5 words. One word is equal to 1 VP. We are going to change 5 VP data, so 05. And timeout is 50 millisecond and 01 mode. 01 mode means we have to mention the page after that. We are going to operate on 0 page, so 0000 is the page, and then the VP address starting is 1010, and the address starting at the slave is 0064, which is 100. So starting from that address, it will update 5 locations. Upload using tfile download method this 22.bin file onto the hardware. Now open the pyModSlave. You update data at location 00. You can see the data being uploaded, that is changed at location 1010 VP. Like that, you can see total 5 word length, 5 VPs being changed. But purposely the VP address, the master, we have provided to 1010, 1011, 1012, and after that one gap we have provided. So in this, because of that gap, one data is not being updated, so it will start from start continuously. Instead of 05 word length, let us use 06 now, and then save this bin file and then upload. Now you can, from pyModSlave, update the data. You can see all the VP address being updated. So the VP address to be contiguous for all the datas to take into effect. This is command 0x03. Next we'll see how to implement all the instructions at the same time. That's starting from 1C000, 16 bytes forms one instruction. Next instruction 1010, 2030. First instruction is from with command 03, 02 is the length and mode is 01, page is 00, VP starts 1000 and the slave address 100. And the next one is command is 03, length 06 words, mode 00, VP 1010 and the slave 110. And the third command at 1C020, we use command 10, and VP is involved 2000 and 120. And finally 1C030 is the fourth command. We use the 10 command, and the VP for 5A is 3000 and data 2010. Save this and upload, and you can see all the effect one by one. The first instruction, that is you can see data being changed at VP address 100. Starting from that, we there are 2 word length is 2, so 2 VP address changes are there from slave, starting from 100 and 101. If you change the value, you can it reflects on the DWIN display. And then the second instruction, here we use the command 03 and we operate on 6 word length, that is 6 VP address starting from 1010, and the slave address starts from 110. So the second row is 110. From that value in the slave, you change total 6 locations. You can see in real time the values being changed at this starting from 1010 VP, all the 6 locations, that is 5 locations being changed. In between we have left on gaps, so we are using 6 word length. And then the third instruction, we use the command 10, which operates on length is 2 word length, that is operates on 2 VPs, and the mode is 00. So it works on all pages, and the VP involved is 2000, and it is decimal address is 120 in slave. So from 2000 VP, feed in the keyboard value 15, it is reflected on the slave. And finally the 1C030 instruction, we use the command 10, operating length is 4 word length, and mode is 02 here, so it looks for 5A lower byte at VP 3000, and if it is okay, it's transfers data starting from 2010 to the slave starting location 1300, which is the fourth series, that is fourth row of the slave is 1300 decimal, which is 0x62. So feed in the data from page 1, feed in the data starting VP 2010, 4 locations, finally touch on send, all the 4 data being transferred to the slave. So this is MODBUS Master on DWIN. Thank you for watching.